Good morning, everyone.
Good morning.
Great. Welcome to this session. I'm so surprised to see so many people here at 9 o'clock in the morning. Didn't you guys go to bars last night? I went, and it was very hard to wake up this morning. So thank you for coming. So a little bit about myself. I'm very glad I'm here in Chicago because I went to University of Wisconsin for my PhD. Thank you. And I feel like I'm back home. This is the area, right? So feel very good about that. Today, I'm going to talk to you about the DR in Azure. Like, what is disaster recovery like? Do you need to do anything? What's the implications in Azure? So I want to really demystify what we provide in Azure and what you need to do for DR. So my colleague Patrick and I are going to do this presentation, and we'll have some cool demos to show you. Those are all the talks in this conference that's related to business continuity and the disaster recovery. There's different scenarios. If you want to look at the most common scenario, on-prem system use Azure as a DR solution. There's a bunch of talks related to that area. And also, we have our own talks about how we build the service, O365 Skype, with DR solution in mind to build those highly resilient services. You can look at them as examples of how resilient apps should be built. A bunch of talks in that area as well. Then we have some prime to prime migration, prime to Azure migration types of talk that's related in this area. I highly encourage you to look at those talks and to really have a great understanding on DR for the whole spectrum. So this talk will focus on Azure to Azure. If you're building applications, leverage the whole Azure stack. What do you do for DR? What are the best practices? That will be the focus for this talk. So what do you want to get from this talk? First, we're going to talk about the platform capability. What are the things we do to make sure our Azure platform is highly resilient, like you can rely on? You can do least work for your app's availability. Then I'm going to also talk about the capabilities. We enable our customers to build highly resilient, highly available apps on top of Azure. Then I want to emphasize what you need to do when you design applications on Azure. What do you need to consider? What's the best practice in your app design such that your app is truly resilient, truly highly available in case of a disaster? So the takeaways, I hope from this talk, you understand that Microsoft is paying attention, great attention. We're doing great investment in making our platform highly resilient, highly available. However, it's also it's your responsibilities to design apps in a resilient way. There's things you have to do. You have to decide whether to buy the insurance and how much you want to invest in the insurance, such that when something bad happens, for example, somebody just by chance click a wrong button, you have a way back. All right, so let's get started. Here is how we're going to talk about those things. First, I'm going to give an overview of the platform. What are the services we have, and what's the implications to you? Then I'm going to focus on 3 core platform services: compute, storage, and SQL. And to show you what are the best practices when you use those different components. Then along the presentation, we'll have a bunch of demos in different sections we're going to show you. Oh, by the way, I love questions. So during my presentation, please feel free to ask questions anytime. And I would love to have this session to be interactive. My goal is for you to get as much as possible from this session. Also, as a bonus, since you wake up so early, right? We really want to hear customer input. So this session is not just one way. It's not just, I want to tell you what you should do, what you shall do. I also want to hear from your feedback. If you're building DR solutions, if you're helping your customer to build DR solutions on Azure, I'd like to hear from you. How do you feel? Are we doing the right thing? Are we heading towards the right direction? Are we providing the set of capability you are actually looking for? Do we make your life easier? Give us all those feedback. And we want to, the reason we're doing this is for you. And we want to make sure we deliver what you're asking for. So after the session, if you are interested, come to me and leave your name. And we're going to work with you to get your input. And of course, answer any questions you may have. Okay? Oops. Okay, all right. So the Azure platform. Is this the first time you saw our data center graph? Please raise your hand if this is the first time you saw this graph. We have a few hands raised. So majority of the people have already seen this graph. So this graph shows you our global footprint, data center footprint, regions footprint. If you look at those circles, each of those circles is a geography. So I'm going to talk about what is a geo. Here, this picture just want to show you a few things. First, we have footprint, data center footprint across the globe. Think about the DR implication here. You can have geo-redundancy. You can have safe deployment across the globe. That's a possibility. The number of data centers, the regions we have in 2015, we have 19 regions global-wise. This is the amount, that's more than both Amazon and Google combined. And I cannot tell you how much money we invest in building those data centers around the globe, but I guarantee you it's a huge number here, how we invest in this area. And our next region, which is going to come up, is India, later this year. What does this mean to you? Before I jump into how you design app, I want to make sure you understand a few key concepts in this Azure domain. So this is the view. Those different circles are the concept, the basic construct we have for Azure platform. Starting with this, so the way to think about this is from a rack to a data center to a region and to a geo. This is the scope of those concepts. Started from the core, the fault domain. Those are the first concepts we expose to user. A fault domain has the implication that we have physical isolation between different fault domains. So things, if some rack, some hardware failure happen, is independent. The rate, the chance of failure happen is independent from each fault domain. That's the first concept. The second concept is region. Region is the concept we expose to user. If you try to provision a resource on Azure, you can choose which region you want to put this resource, giving it compute, a VM, a database. You can choose to deploy your application to the region that's either close to your customer or for whatever business reason. A region has one or more data centers, but data center concept is not exposed to you. You cannot choose which data center you want to put your application. On top of region, geography. This is a very important concept. A geography contains one or more regions, at least two. Two or more regions. Each geo has at least two regions. For geo, we have a very strong guarantee. That is data redundancy. Data, customer data that's deployed in one geo, we have this strong guarantee. The data will remain in that geo. You can think about this guarantee is important for lots of government regulation and all that. For example, in China, we have this whole national cloud. We call China is a geo, and it has two regions, China East, China North. The data deployed in China geo will remain in China. It will never leave the geo boundary. So very important concept. Why do we have two regions inside of a geo? Is to provide the DR guarantee. The regions are designed physically isolated from each other as far as possible, such that any natural disaster, we want to have isolation between different geos, between different regions. So geo guaranteed data residency. At the same time, guaranteed disaster recovery capability across regions. So those are the constructs for Azure. And then at the cloud level, beyond the geo, we have global cloud. There's a few types, depends on how we do the operation and all that. For example, we have the most widely used public cloud. We have the figure I showed you before. Majority of those geos you see here are public cloud. And then we have two. Right now, we have two national or sovereign cloud. One is we call it Mooncake, the cloud in China. This afternoon, we have a talk on our national sovereign cloud. You will hear about the cloud in China and the US government cloud. Those are the cloud designed to satisfy different compliance, different regulation for different segment, different customer need, such that everyone, for your business, for every need, you can find one offer in Azure that meets your business need. So an important concept, once you understand, any questions about the concept, the construct? All right, so one important concept here is paired regions. What are the paired regions? In each geo, every region has a paired region. We call it a DR pair. So for those DR pair, we have guarantees in physical isolation as well as logical isolation. For example, we make sure when we have update to the region, we make sure that update will not happen at the same time for two paired regions, such that if we have bug in one region, at least the DR pair, the other one, is not impacted. Right? So think about the DR pair as the strongest guarantee we can achieve to provide the DR isolation, both physical and logical, to our customers. All right? So we have an exception. So I talked about data residency guarantee for geo, right? Which should mean that all the data in one geo should remain in one geo. We have an exception, Brazil region. The Brazil region is paired up with a North American region. Don't ask me how we got to that design. All right. So here I have a list of the paired regions. You can see each paired region is how do you say that? One region is paired with another. They're mutually DR regions. So this list is published in the portal. So with our expansion, we're still building data centers, expanding our data center footprint. If you want to get the latest region, DR region pair map, go to our portal, and those are always up to date. All right, so with our DR paired region in mind and all that, now let's look at what type of services in terms of DR design we provide to you in the platform. So this table actually comes from the Azure portal. So if you go to the portal, you want to provision resources, you will find all those drop-downs from compute, website, data and storage, so on and so forth. Regarding DR, we divide them into two different categories. The first category, we call them regional service, which means you, as a customer, you decide which region you want to actually deploy your resources on to, giving it a virtual machine or a SQL database. You have to choose which region you want to put those resources in. For in-region, Microsoft guarantee high availability. You don't need to think too much to work too much on, okay, how do I make sure my database is available inside of this region? We do lots of work, and I'm going to explain to you to guarantee that high availability in region. However, if it's a cross region, let's say there's a disaster, the whole region just had an earthquake, what's going to happen? To you, this means you'll lose your service. If you have a database in this region, only in this region, you didn't use any other DR design in your application, you'll lose access to this database. Okay, so there's no cross-region guarantee for regional services. The second type of services are we call global or cross-region services. For example, the portal. For example, identity, networking, so on and so forth. For those global services, the guarantee Microsoft has is cross-region. You will get a cross-region HA. You you don't have to do much. Even when region is done, to you it's irrelevant. You don't mind, you don't really care if a region is done, is wiped out, because those type of services will always be available for you. As you can see, the regional service is the majority of the services we provide on Azure, for good reason. Customers really need to know, because normally when you design an app, you want everything to be close together, right? We really want to make that transparent to you, such that you can design it accordingly based on your performance need, based on your availability need, your business need, right? Any questions? All right. So far, I've talked to you about the basic overview related to DR, the basic concept, and the type of services we offer in Azure platform. Now, in the next section, I'm going to drill down in each of those core platform services and to explain to you what are the things we do for the platform to be highly resilient. What are the capabilities we provide you to design your DR solution? And what are the design patterns you may leverage, and we highly recommend you to leverage, and to design your app in such a way you can fully leverage the capability we provide and make your application highly resilient to disaster. So I will start with Azure Virtual Machines. So first slide, Azure Resource Management. Please raise your hands. How many of you have heard of this concept? ARM. Okay, I saw quite a few hands raised for this concept. So Azure Resource Management, this is we announced this in Build.
Mm-hmm. George.
Yeah, George. Yeah, so I have a few colleagues sitting in this corner. They're going to answer the tough questions you may have. So we announced this Azure Resource Management in Build. This is the new implementation, new design we have. And the biggest benefit for this ARM design is really for our control planes to be highly resilient in region. So what this is talking about, so this is completely transparent to you. This is telling you, like for the provisioning, for the control plane, for compute or for networking, a few core services the platform provides. We do a large amount of work to make sure they're resilient in region. And so, okay, another point. The reason I want to talk about how we do things, how we want to achieve high availability in region or cross-region, how Microsoft does that, is also to give you an example of how to think about this problem. Think about the design pattern we actually leverage. Those can be the design pattern for you as well, right? So we practice what we propose you to do. You can use how we do things as an example to really design things in the right way. So for this one, for ARM, this is how we achieve in-region high availability. We actually, this is an example from one region. For different clusters, we deploy, for this control plane, we have multiple instances across different clusters, and we have this concept called service ring. And doesn't matter which cluster is done. This is transparent, completely transparent to you. The service will always be available in region for any hardware failure, rack failure, so on and so forth. So the failure of the entire region really will not impact the failure of another region, right? So what that means is if a resource provider, if an ARM service is done in one region, it will still be available in another region. This is completely isolated. And guaranteed in region HA. Users, you don't have to worry about, okay, what do I need to do for those control plane? Always, it will be available, highly available for you. So this is one design pattern we have. And if you're interested in this design pattern, we have a service fabric, George? Service fabric, right? So service fabric is the magic behind this thing. The ring we talked about and the automatic failover, all those magic is provided by service fabric. That component is what SQL Azure, SQL database is built upon. Right? So we leverage that framework, that lower level infrastructure to achieve high availability for our own services. For example, SQL Azure. And right now, we're exposing that internal infrastructure to you, such that you can also leverage to build service rings and all that. The work is not trivial. I think about how many people working on SQL Azure on the Fabric ring, the service ring, to make those things work. However, it's available, and if you leverage those infrastructure to build your application in such a pattern, it's way easier than when you want to build your own fabric. Okay, now let me move to what's the responsibility for you. So I talked about for control plan. I assume everybody understands the control plan. Is this wrong? Okay. If you don't know control plan, please raise your hand. Okay, good. So we differentiate our cloud services in two different dimensions. One we call data plan. That's the customer data. If you have a database, that belongs to the data plan part. Customer data, customer app, customer resources. Control plan is the metadata, is the mechanism, the routing table, whatever. We keep to make sure our service is running. Right? So the control plan, if the control plan is done, everybody is done. If a data plan, part of the data plan is done, it only impacts part of the customer. So you can see for Microsoft, the control plan is critical. We want to make sure control plan is highly available in region, across region, so on and so forth, right? Because you don't want any region is done, you still want to continue provision resources. You still want to access to resources in another region. That's controlled by the control plan. Okay, make sense? All right, so we talked about the control plan Microsoft provides. Now, let's look at if you are deploying resources, if you want to achieve in-region highly availability, how do you do that? So we have this concept. I talked a little bit, I mentioned about fault domain. We also have another important concept called update domain. So we allow customers to define availability set. And the availability set, the purpose is really to make sure you have as much physical isolation, logical isolation as possible in region. Right, so I have an example here. So each vertical bar here is a fault domain. Think about the fault domain as a rack. So if something goes wrong for a rack, the whole rack is gone. Okay, so that's why we call it fault domain, physical isolation from each other. Then we strip portion of a different portion from different fault domain to form an update domain. The update domain is designed to have logical isolation. We make sure when we update the virtual machines without in different update domain in sequential order. So we will never update the same thing for two update domains at the same time. You can imagine we have bugs in code, right? Even Microsoft does. Maybe more than you do. So we want to make sure if we have logical bug we rolled out, at least different update domains are impacted differently, right? So this is an example of an application. It has 3 rows, A, B, C. And for each of those row instances, we have 3 instances. And here is how we deploy it. If you look at the color, we have the orange, yellowish. This is 1 row and 3 instances about this row. And then we have row B, row C, the blue ones, the purple ones. As you can see from this pattern, what we guaranteed is actually for each row instance, they belong to different update domain as well as different fault domain. If you deploy your resource in such a way, if you form each of those, like the orange one, the blue one, and the purple ones, each of them is called an availability set. If you deploy your resource in such a fashion, you will be able to leverage the whole isolation, physical isolation, logical isolation for in-region high availability to the maximal extent. Does it make sense? So basically, the availability set has, as I said, 2 strong guarantees. One is physical isolation, one is logical isolation. That's how we recommend you to design your availability set for in-region, for your resources. So here I have a snippet of how you do this in code. Right? For each availability set, you can specify up to 3 fault domain, and you can also specify how many update domain you want to put the resource in, and we will automatically guarantee the deployment satisfy the requirement you specified. So this is how you achieve HA in region, right? What you can do very little to leverage the platform capability. So let's look at how do you design the app for your compute resources such that it have highly resiliency across region. So here is a design pattern, the best practices we recommend. So as you can see, here we have, for the whole stack, from compute and for your storage need, we deploy them, we recommend to have those resources across regions. Ideally, a DR pair, right, for those logical and physical isolation. So we have this, another resource called Azure Traffic Manager. So you have to, this is a key concept. When you design an app, it's not just a compute, it's not just the storage. You need everything, right? You need a storage layer, data, you need a computer layer, and you need to configure DNS, you need to do load balancing. The whole app needs to be designed, taking into account of DR capability, right? So here, this figure just shows that. We have quite a few nice properties for the traffic manager to make your life easier for this pattern. You can design, for example, where you want to route your traffic, right? So you can route it to only to one, keep the other just passive. You can also use round robin to route your traffic dynamically to either of those deployments. And a good thing about this one is because you're handling traffic in both sides, for one, you get load balancing, right? You get a more benefit out of your deployment. For two, which is even more critical, is you exercise your DR all the time. You know if one of those deployment is done, the other one for sure is working because you're actually exercising that site continuously. And I'm going to talk more on SQL later on. So this is from high level, what's the whole stack of app design pattern you have, we recommend for cross-region failures. Okay, just to recap for that design. Traffic manager. This is really the global load balancing mechanism we have cross-region. And for the compute availability set, we already mentioned that in previous slides. And for SQL, we're going to drill down later in the SQL section. One thing I want to mention in this slide, the biggest takeaway. We have lots of templates for you to use for that app design pattern. So you can easily leverage a template or just make an extension such that you can easily make those deployments into reality. Less work on you, more benefit will provide it across the platform. All right. So we talked about the compute layer. You design the whole app in redundant regions to have DR capability. Now let's talk about the data. So I'm going to first talk about the SQL, and then I'm going to talk about the storage. What are the design patterns we have? So SQL virtual machine. How many of you use a SQL virtual machine versus the IaaS? Could you please raise hands? It's like 1/3. How many of you use Azure SQL databases, the PaaS platform? Also quite a few, right? So IaaS is the most natural way for people to extend, to start to use cloud for obvious reason. The difference, let's say, it's much less for cloud and for on-prem, right? It's backwards compatible. It's basically, you don't care whether it's on-prem or it's in cloud. You see the same SQL Server. So for SQL, let's talk about in-region HA and between-region DR for SQL Server. This really has no difference. That's a little difference than on-prem SQL Server. For SQL 2012 and SQL 14, we already provide those availability set, right? Availability group. And the same thing can be used here for virtual machines. So let's look at within Azure region. Within Azure region, so what we want to achieve here is how do you have databases in region, and you want to make sure your database is always available. This is the virtual machine. You know SQL Server can go down, the virtual machine can go down, right? How do you achieve high availability? Similar pattern, you want to have multiple copies. You want to make sure if one VM done, you can easily have another VM. So we just leverage the same feature set, availability group as in on-prem, right? As in this diagram, you have different VMs, you have more than one copy, they're all in the same availability set. And if one is done, you can easily just fail over, make the secondary as the primary, and then establish a new connection, a new secondary. Then life is good. So SQL provided the very strong customer features such that you have less work to do. It's just the configuration. Also, of course, it's a price point, right? If you have the right addition, the right package, it's easy for you to leverage those features for in-region. This is SQL always on, right? It's on-prem, the same for the cloud VM, right? This is somewhat different for across region, for availability group. So for on-prem SQL Server, if your customer really want to have high availability across different data centers, even for you, you would have to design the availability group across different data centers, you may not call it region. It may really hard for customers to really have different regions across geo and all that. In Azure, this is way easier, right? Because we have those footprints, and for you, is to choose your deployment in such a way. You can leverage cross-region availability. So we extend the availability group always on to support cross-region VMs to be put into the same availability group. So the guarantee you get here really is if you have a natural disaster in one region, the other region is not going to be impacted. Right? Same concept of availability group, no additional work. It's just a stronger guarantee because your data center is further away from each other. Natural extension for the in-region. And again, to leverage this feature is super easy. These are some screenshots from the portal. We have a template for you to use to deploy availability group. So I think for now, you already see the pattern, right? We want to give you the capability, but also, very important, we want to also make sure the deployment, the design for you is as easy as possible. So we have all those concepts of template such that you can easily use and deploy stuff in different regions. You can repeat those operations easily. Okay. So we talked about the VM. That's the majority, the same on-prem features we leverage on Azure, right? Now, let's talk about the PaaS platform. This is the Azure SQL database. What can you do here? What are the things we provide? So here, I have a chart on what are the things, the features we provide from the platform point of view, and what is the responsibility on your side to leverage those features to make sure your app is highly available. So we give you lots of features. We give you geo redundancy, geo distributed service. We give you failover. We give you active geo replication. We give you point-to-time restore. Lots of things, lots of features. What do you have to do? You need to make sure you actually leverage those features. You have the reservation of resources. You turn the knobs on. And very importantly, you actually do those DR drills. Right? You want to really test, is your backup working? Is the failover working? Do you have the right process in your business such that when something happens, you can easily failover? And we enable you to do those tests easily. Okay? So we give you features, but you are the key to leverage those features. If you don't use them, there's no magic. Something happens, your resource will be done. So we have a different pricing tiers, basic, standard, and premium. For those different pricing tiers, if you look at the capability-wise, naturally, the higher the version, the addition is, the stronger guarantees we have, the more flexibility you have, the more redundancies you get. And you can look at all those information are in the portal. So this is just a snapshot. And again, this is just look at different capabilities, what's covered in different edition, basic, standard, and premium. For premium, I just want to emphasize a few. What you get from premium, what it allowed you is active geo replication. So what you get there, so for geo replication, you have an active, passive kind of pattern, right? So even you have a secondary, the secondary cannot be read. Only when you fail over, the secondary will be activated. The major difference with active geo-replication is the secondary is available. You can use it to read all the time for read. And what does that enable you is basically you have two databases available. So you can always do online upgrade, online app migration, because there's always one available. If you just you want to do any change, you change one. When everything is done, you switch over to the other one. That's naturally you get online app upgrade and the replication. All right, so there's two solutions, two design patterns for Azure SQL database. So we talked about replication. And replication is not the solution for all issues, right? This is always very confusing to people, even for Microsoft people, right? We always say, okay, I already have replication set up. Why do I still need a backup? Do I need a backup? Nodding. Everybody needs to nod. Yes, we need a backup. What does backup give us? You have not only, so replication just make sure two things are always up, right? It's really for fast recovery. But it doesn't give you everything. Think about if a user just randomly, accidentally delete a database. You want to be able to bring it back, right? You want to, for compliance reason, for human error, for lots of things, you want to know what's in the history, right? You want to be able to recover from a backup before. That's very different guarantee than replication. You need both and your business need, right? With replication, you get really fast recovery because the secondary is always kept up to date. But with backup, you have stronger guarantee in you can go back to date. You can find different, much more disaster type, and it will work. You can recover from much more disaster type. So I will talk about those two. So this is backup-based solution. So point-time restore. For Azure, so if you have on-prem, you need to define how do you do backup, how do you set up backup policy, right? So actually, this is a little story. So now I work in the Azure team. My team, I'm leading the BCDR for Pan Azure, how we design our platform that's resilient, and what are the capabilities we want to give to customers. Those are my current charter. Before I moved to Azure, I actually worked in SQL, and I worked on manageability for almost 9 years. So one biggest area is this: how do you do backup? How do you set up backup? Because this is the toughest thing to do for DBAs, right? You need to decide how do you do. We have full backup, differential backup, and log backup, all kinds of concepts. How do you set this up? Cloud makes this easier. PaaS makes this easier. We automatically do the backup policy for you, implement the backup policy for you. We set up daily backup, full backup, weekly full backup, and we do daily multiple times a day for differentiate backup, and then we do log backup to guarantee if you want to recover to one point of time, you actually have lots of options. Then depends on the service tier, basic, standard, premium. We keep the data we have different retention policy, right? You can imagine naturally, the more you pay, the longer we keep the data for you. So anytime, all you need to do is to hit, I want to restore. You choose which data point, which point you want to restore to, it will happen. So you don't need to worry about the setup. How should I do backup? We do that for you. So those are the things you get from the PaaS platform. All right. Don't want to move. Okay, so that's a point in time restore. If anything went wrong, you can always go to a point of time. And this one is geo restore. What this one does is a stronger guarantee. By default, you don't need to do anything. Everybody, even for basic version addition, you get this. We back up your data, leverage Azure storage. We back it up, and we also make sure the backup is done in geo-replicated fashion, right? So if one region is done, your database, even you don't do any, you choose not to do anything about it, the data will be available. So if one region goes down, all you need to do is to choose to restore the data from another region, the blob store, back into another server. So this server can stand up and run, and you still have access to the database. Think about the limitation here, right? So this is not all rosy. If you have huge databases, which are in the blob store, the the recovery time is going to be long because you need to hydrate the database, right? You need to hydrate the server. So really, if you don't, although you have the guarantee that data will be here ultimately, but you might have a big window, depends on your database size. If you only leverage the basic feature Azure provided to you. But if you have smaller databases, it would work really fine. And also another thing is for geo restore, you cannot really initiate failover before Azure. So you cannot control failover for in this case. What will happen is this. If I lose a region here, first, Microsoft is going to try its very best to recover from this region because failover is expensive. You have lots of manual operations. Many places can go wrong, right? We'll try our best. If everything fails, we decide, okay, we need to failover. We would notify the user, please failover to another region. We give you 1 hour to failover your application. If you don't do that, after 1 hour, it will automatically failover for you. And then the second, this will happen, right? Data will be hydrated, and another version will be, then you can leverage the storage, the blob store, and you can click the button to hydrate another server. However, one caveat, the capacity is not reserved for you, right? Even you have the capability to really restore to a server. If you don't have that resource reserved, we may run out of capacity. You may not be able to really get a server when one region is done. So those are the, if you want to look at DR, you really also need to look at the capacity planning. How do you want to reserve those capacities in advance in case something happens that you can actually make the backup work? All right. So that's a geo restore. So we have point-in-time restore, we have geo restore. Those are for every edition, and you can do that for every edition. It works. And then I talked also about the area, the caveat, that what you need to pay attention to. Now let's look at replication-based solution for PaaS. So we have 2 important features in this for replication-based PaaS for SQL Azure. And we have talks from the SQL team talking more, drill down more about how you set this up and how it works in detail. Here, I will just give you an overview, a high-level overview. So for standard geo-replication, here, if you recall, East US and West US is a DR pair. So by default, you cannot choose which region you want to use for this standard geo-replication. By default, if you choose geo-replication, we just choose to replicate the data always into a paired region. So compared to the backup, you never need to hydrate this server, this database in the secondary, right? So because the synchronization between those 2 regions, between primary and the secondary. So the RTO is much shorter. If this region goes down, all you need to do, you can control failover. You can say, okay, now I want to failover. And then this region will become primary. And if this region is done, if the primary region is done, we actually allow you to establish the primary-secondary relationship with a selected region. After this region, the new dedicated secondary for this original secondary region. Does it make sense? So as you can imagine, if you have huge databases, if you have huge data in the database, this really what this gives you compared to backup-based solution is this very short RTO because 2 servers is always in sync. However, you only have 1 secondary, and it's offline. You cannot do load balancing on it. So this is the ultimate feature, active geo-replication. With this feature, what you get is you can get 4 copies, and you can choose where those 4 copies are for your database. It can be cross-geo. Not only that, the secondary is readable. It can accept read workload. So think about if your business expanded to different regions, you have different customer base. You may want to have this capability to workload balancing your request into different regions, such that the request can serve the customer with the closed approximation, right? And then with this active geo-replication, again, customer control failover. Not only is readable, anytime you can say, okay, and switch to the other one. So you get a few benefits out of this. Because you have the read-only traffic, again, DR geo, by default, you already exercise the secondary all the time, right, across geo. That's a great thing. You know it will work. And secondly, you have the guarantee across much more area, so stronger guarantee. And the third thing, you have load balancing. You can leverage them. It's not just money reserved for disaster. You can actually make some return out of the reservation you have for disaster case. So this is just a... All right. OK, now I will ask Patrick to show you a demo for this SQL application.
Howdy, y'all. And what makes this active?
F7.
OK, so what I have here is a demo website, and this is, it's got 2 complete stacks in 2 regions. You're in front of the speakers there. You need to go over here. It's 2 complete stacks in 2 regions, and they're sitting behind traffic managers. There's traffic manager, there's cloud services running IIS, and then there's SQL databases doing the active continuous replication. So first, I'm going to go in here and actually buy a ticket, and then you will see this replicate, and then I'm going to live dangerously and induce a real failure, and we're going to watch traffic manager fail over. So let's go into here, and I'm going to purchase some tickets. And okay. Okay, I purchased some tickets. And if we look in my events here, we will see this Kansas Expo Center. And so this went to the primary in one region, which is replicating to a secondary in a separate region. Now, I'm going to go in here into an RDP session to the cloud service, and I'm going to stop the IIS service in that primary. And then what we will see, let's see, so here's Traffic Manager. So Traffic Manager is going to detect this. It still shows online. It's going to refresh in a few minutes, and we're going to see this in a degraded state. And then we will see it fail over automatically to a second stack in the other region. So while we are waiting for that to happen, can you switch back to this? Well, let's look at the architecture of how this works.
Go back to my
Yeah, go back to yours, yeah. And let's go to the next slide. Okay, next slide. Okay, so what we have here, this is the overall setup of this demo. So you have Traffic Manager, and it's set up in the failover mode. So there's a round robin, there's a load balancing, and then a failover configuration. You can add multiple endpoints. It will probe those endpoints, and it will fail over after a timeout value. And so it starts off running to this primary, and then there's a SQL database that's got the SQL GeoDR replication, the continuous copy, and that's only available. You have to have the premium SKU to do that. And then the sharded database is for another part of the demo. So what we will see here, hang on just a second. Let's refresh this. Okay. And it may take a minute to refresh. Let's see if I did this the right way.
Okay. While you refresh, I will continue.
Yeah, continue on. It's going to take a minute for this to catch up.
So while we're waiting, I will proceed to talk about the storage, the last component for the core platform. So any guess what's the most used resource in the whole Azure stack? Storage, compute, website, SQL. Give a guess. Yes. So, actually, sorry. Storage is second. The first most used resource is websites. Storage is the second. Not hard to imagine, right? Everybody needs to store stuff. For any application need to work, you need a storage. So it's important you understand what is the guarantee for storage and what you need to do for storage DR. So again, very similar slides as SQL. We provide you a set of features. We have a few features I'm going to talk about in next slides. But on your side, you need to leverage those features to design your app, similar design pattern. And here are the features we have. We have a few things: LRS, GRS, and RAGRS. LRS, locally redundant storage. This feature means we keep several copies for the same region for you, right? So in region HA. GRS and LRS is done synchronously, strongest consistency guarantee. Then we have GRS. This is geo-redundant storage. So we keep another set of copies for you. For each of the copy in one region, we keep a copy across region for you. And those are done for performance reason asynchronously. So what do you sacrifice? Consistency, right? Eventually, you'll reach a consistent state, but there is possibility that it's not consistent. Then we also have read access GRS. What this one is similar to the SQL pattern. Your secondary is readable, so you can direct read traffic into the secondary. Question?
Yes, with the GRS and read-only, if you get down in a region, how do you make that writable, or do you have to copy that entire blob and push it somewhere else? Is there a certain script?
Yes, very good question. So the question is, for the read-only GRS, when one region is done, how do you make the read-only secondary become writable? I'm going to talk about that design pattern. That's a good segue. Okay, all right. So those are the design patterns for storage, for cross-region DR. So we first have read-only secondary. Then we have multiple read-write accounts plus read-only secondary. Then we have a technology we actually provide as an open source framework for you to do different set of things. So those different design patterns are suited for different app purpose. Read-only secondary is designed to optimize for highly available reads, okay? And it gives you eventual consistency. However, if you have lots of writes and you want to make sure, so think about what this one is missing. If you have writes, when the failover happens, right, you cannot really, you will be blocked because the writes won't go nowhere. The secondary is read-only, right? So this design pattern with multiple read-write account is the design pattern to solve the question that the gentleman asked, and I'm going to drill into it. For both of those two design patterns, what you get is the eventual consistency. If you require strong consistency, we have this technology called R-table, replicated table, which is synchronously copy things into different places, such that you have that stronger guarantee for consistency. So let me drill into it. This one is read-only read access GRS. So what happened here is this: the write traffic goes only to the primary. Read traffic, though, can go to both primary and secondary. And again, in the application, you can actually choose. We have a client library for you to choose how to route the read traffic. You can either use primary first, or use secondary, or use round robin. Again, with round robin, what you get is you exercise the secondary all the time, and you get load balancing. And the key takeaway here is for consistency, you have to understand all the writes goes to only the primary. And the reads to primary, of course, is consistent. But the reads to the secondary is not always consistent. We call it eventually consistency. So it's the app's responsibility to monitor the replication progress. We give you all those monitoring capability. You need to leverage it to see how long, what's the traffic right now look like, how much lag you have from primary to secondary for the replication, such that you can control the data loss window based on your business need, right? So you need to do that. You need to monitor the traffic and make sure the lag is acceptable for your business. And this one is read-write secondary, right? So in a workload where not only read is critical, but write is also critical, what do you have to do? The secondary will only allow you to read. We're working on it to make it more flexible. But right now, what you have to do is this. we recommend you to use this design pattern. You should have multiple primary reserved, right? So in the normal traffic, the normal path, again, you have an application, write, which is the red arrow, goes to primary. Read can go to both primary and secondary in case of failure. What you do is, if you have append only, add only traffic, you will do your write to the new primary. Read can go to both primary and secondary. However, if you also have the choice to first copy over what's in the read-only secondary, hydrate that with the primary, such that you can do modification in the new primary. So there's quite some work on the customer side to implement this read-write pattern. Depends on your logic. You can do either copy those data over, or you can just have the logic in the application to know. Now, from now on, for any write, for the new write, you read from the new primary. For old existing data, you read from the secondary. So it's up to you to decide what's the right logic based on the specific need for the app. All right. So the third design pattern is the R table. So this is a replication framework we have, and some of our services. By the way, for all the design patterns I talked about, our services actually leverage them. For example, Skype and Xbox, they are designed to either use the read-only secondary or the multiple read-write primary. So those are actually the design pattern our application itself uses for DR. So this one, the round table, it's just a set of client library. What it does is it intersects all the writes and the reads from the application, and it simultaneously route those writes into different replicas. So as you can see, this gives you a stronger guarantee because writes happen at the same time. So, and then there's work for you to leverage those client library. So really depends on what's your tolerance for consistency and what's your need. It all comes from business need. Then from the need, you decide which design pattern suits your application the most. So can we now see the...
Ready, yeah.
Now let's go back to see the failover for SQL.
Okay, so now we have the site as it was before. And if you look at Traffic Manager, you'll see that the endpoint is degraded. So what this means is that it has detected that the endpoint was down, and it has gone to a secondary endpoint, which I've defined in the secondary region. And so now this site will, we can go in here to my events. Let's see, refresh this. Okay, and let's see my events. And when this comes up, we will see the tickets that I purchased in the other site. So a key point here, and someone asked about the read-only versus read-write. The concept applies to SQL as well as to Azure Storage. With SQL, the secondary is read-only. And so this site's configured to always provide read access. If I were to want to fail over and have it work and be read-write to the secondary, I would have to take an additional step. So the way we think about this is we provide the read access, which you can always have. And the decision to fail over your writes is really an application level decision. You have to decide what your data loss tolerance is and if you are willing to do the failover. So to transform this to be a writable secondary site, you would then take another step to convert your SQL database into a standalone primary, and then we can continue the writes. And it looks like it's taken a little while to refresh.
Should I go back to continue?
Well, so should I do the other two demos? Are we just about out of time?
Yeah, actually, let's proceed. We don't have time to wait for the failover. Let's look at another two demos we have.
Okay. So let's see. So in this demo, so we talked about, so Azure Storage provides you with the primitives to implement cross-region high availability. And then you have to do work on the application side depending on the requirements of your app and your data loss tolerance. So within Microsoft, services have implemented their own types of failovers and replication schemes. And some of those now we're turning into open source frameworks. And so the first one is called Rtable. And what Rtable is it's synchronous replication across n number of regions. And it was developed by the Microsoft Research Group in partnership with the networking team. And I'm going to kick off a demo here and show you what this does. So excuse me, in perfmon here, what you see is this is writing to, oops, in a second. There is an issue with these counters. Hang on a second here. Okay. So what I'm going to do is add these counters, which are going to monitor the writes to the primary and the secondary and the total number of writes. Okay. And this. And come on. And 2. Okay. Okay. Now we'll start this off again. Okay, so what you're seeing here is writes going to, this is the total writes here on the left. The middle one is writes to one region, and the right one is writes to a separate region. And so the way Rtable is designed is it's synchronous. So if it cannot commit to all regions, it will block progress. So here it's successfully writing to both. So now I have a command here to simulate a failure in one region. So what this is doing is, see back here? Okay, so now you see that writes are only going to a second region. So what this has done is it has simulated a failure in one of the replica sets, and then it has removed that replica set from its inventory. So now it's making forward progress from the secondary replica set. So this, you have control of all these things from within the Rtable library. So now another thing that Rtable provides is the ability to repair. So now what it's going to do is return that replica set back to the pool. Let's see here. And so one really nice thing about Rtable is it will then take your replica, which may have fallen behind. It will commit writes to all replicas in the set, and then it will also catch up. So this one now will be going faster than this, and eventually these two will be in parallel, and you will be back to full data parity across regions. So Rtable is something that we provide to you through GitHub. It's an example. We don't have an SLA from it, but it's the kind of thing that you can build on top of Azure Storage. We encourage you to take this and look at the code and modify it to meet your specific needs.
Okay, all right, thank you, Pat. So now let's switch back to the presentation. So we talked about the three core components: compute, SQL, and the storage. Now let's look at, there's one more thing. So when we talk about the storage, when we look at the replication, it's at the storage level. But sometimes, let's say, majority of the time, your storage is used as a disk for your virtual machine, right? If you only replicate at the storage account level, it doesn't really give you the consistency across different disks. So we have another thing called Azure Backup. This is another feature, another service we provide to provide you a higher level consistency for the VM disk. So this have the understand the app logic, and it makes sure that the replication, the backup happens consistently at the application level. And you can control the frequency of backup and lots of features with the Azure Backup. So again, storage depends on your business need. Storage replication is lower level at the storage account level. It applies for blob, for table, for queue. For some business needs, that's all right. But for VM, you might want to consider this application level backup offering. All right, so we already see the demo. Now, we talk about the core component. We talk about what you should do, what are the design patterns. Now, I will show you an example. We actually, Microsoft MCS, consulting services, we actually helped the client to build for Olympics event. how we design DR and how it put things together and how it works. So I cannot mention the name of the Olympics. This is the website where you can users around the world can really see updated information about what's going on, the update about the events, right? So, and you can imagine the importance of the availability of this website for commercial, for whatever reasons, right? We don't want to lose availability. So DR is top priority for this application. So this is what you see, the live update. When something happens, when the event is even happening, end user can actually get that feed from any iPhone, Windows Phone, whatever devices they have, and get the latest update. And the website has to be always up. So this is, in a nutshell, how the high-level architecture look like. The core of this design is on Azure platform. You have the front end, back end, all the compute, the storage happens with Azure platform. Then, just by choice, we choose Akamai, third party, to do the content management, the content feed, and traffic management. So what's the design? Does it work? No. Yep. Okay, thanks. So this is the resources this app leverages. Lots of cloud services, lots of storage account. And then it uses service bus, it uses VNet. Those are the stats about this application, the real application. You have to serve a huge amount of traffic for this website. And it delivers huge content, serves huge throughout of traffic. This is how they design this app. First of all, they differentiate front end and the back end. The front end is only light web application, and it's stateless. And the back end stores all the state, all the content. So, which means the front end can be anywhere. And as long as it can connect to the back end, it can serve the end user request. Any component in this design can be done. That's the assumption we have. We don't assume anyone is resilient. So the design has to take into account any of those core components can be done. What do you do to make sure the website is always available? This is how we designed it. First, backend. We leverage, so backend, you can think about our data, right? We use storage, we use SQL. We made sure that the backend is replicated. You always have the content available, even in case of region loss. Then, for the front end, again, it's deployed across multiple regions. For two reasons. We leverage the different deployment for load balance as well as for DR. If one region down, that's okay. You just lose some capacity. But the rest of the request can be served by the rest of the available regions. And then it's connected with the content management. All right, so this Olympic support will continuously with upcoming Olympics. And this is a real example to show you. Leverage Azure, how you can actually design the app that's highly available, even in case of failure. And it's durable. So with that, I will wrap up this session. If you have more questions, please feel free to ask. And even after the session, my colleagues and I will be available here. Remember, I want to hear your feedback, your input. We are doing great investment in the DR area. We're building features. We're building more and more capability. We want to hear from you. What do you need? How can we make you successful? So come talk to us. We'd love to work with you. Thank you. And please do evaluate the session. We want to make sure you get the most out of the sessions. So tell us how we can improve.